Good afternoon, everyone. So this afternoon, we will be discussing about the linear inequalities in one variable. Our objectives for today. First, define linear inequality in one variable. Second, differentiate linear inequalities from linear equations. Third, solve linear inequalities in one variable. And last, translate and solve real-life situations involving inequalities. So what is linear equation in one variable? Can you give an example? So example is 2x plus 7 is equal to 11. What do you think will happen to the solutions if we change the equal sign to less than, greater than, less than or equal to, and greater than or equal to? So it becomes 2x plus 7 is less than or equal to 11. If you need at least 50 pesos to buy lunch, how do you show that in math? So this situation implies the use of inequality since we are using the word at least 50 pesos. So let us now define. A linear inequality in one variable is a mathematical sentence that uses inequality symbols less than, greater than, less than or equal to, and greater than or equal to. Examples. X plus 1 is less than or equal to 5. 7x plus 9 is greater than 72. 3x minus 1 is greater than or equal to 5. And 2x minus 8 is less than 2. So symbols and meaning. So this symbol is a less than. One number is smaller than the other. This symbol is a greater than. One number is greater than the other. This symbol is a less than or equal to, which means either smaller than another number or exactly equal to it. This symbol is greater than or equal to. It means either bigger than another number or exactly equal to it. So let us now differentiate linear equations and linear inequalities. So first, we have the exact solution. So for the linear equation, we only have one exact solution. It has a balanced or equal expression, and it uses an equal sign. For linear inequalities, the possible range of solutions, there is comparison in our equation, and we are utilizing these four different symbols. The less than, the greater than, the less than or equal to, and the greater than or equal to. So example of a linear equation is x plus 8 equals 12. 12x minus 8 equals 9. 4x over 3 plus 2 equals 9. For linear inequalities, we have 16x is less than 32. 24x minus 15 is less than or equal to 45. 5x over 3 plus 8 is greater than or equal to 2. So let us now have this exercise number 1. Simplify the following. So x plus 5 is less than 12. So just like the equations or equality, we can just simply use transposition. So from positive 5 on the left, we can transpose this positive 5 onto the right, and it becomes negative 5. So x is now less than 7. So this is how you're gonna solve for the value of x. So what are the values that are less than 7? So we have 6, we have 5, 4, and so on. Another example is 4x minus 7 is less than 9. So just like what I've mentioned, we can do transposition by transferring the negative 7 onto the right. So negative 7 becomes positive 7. On the left side, we have 4x. So we can just simply combine the right side of this inequality, which will become 16. And we divide both sides by 4. And x is now less than 4. So what are the values less than 4? So we have 3, 2, 1, and so on. Another example is 3x greater than 9. So, since we don't have another constant beside 3x, we can just go ahead and divide both sides by 3. X is now greater than 3. So, values are any number greater than 3, like 4, 5, 6, and so on. Another example is 2x minus 4 greater than or equal to 6. So, we transpose this negative 4, it becomes positive 4. And we add together with 6, that becomes 10. So we divide both sides with 2. We cancel out the 2 here. And x is now greater than or equal to 5. So 5 is included. So your values could be 5, 6, 7, 8. It could be a whole number. It could be a fraction or decimal. Another example is 4x minus 1 is less than or equal to 7. So we transpose this negative 1, which will become a positive 1 on the other side. If we combine 7 and 1, it becomes 8, and we divide both sides with 4. And that gives us x is less than or equal to 2. So let us now proceed to the problems involving linear inequalities in one variable. Problem number 1. A student needs at least 75 points to pass a test. Write and solve the inequality. So let x be equal to the number of points. And for the equation, we write x is greater than or equal to 75. Take note of the word at least 75. So it means your minimum value is 75. So any number higher than 75 is actually our part of the solution. A jeepney can carry a maximum of 20 passengers. If 14 are already inside, how many more can still ride? So if we are to let our variable x represent the unknown, it will be the number of passengers. For the equation, we have x plus 14 is less than or equal to 20. Take note of the word maximum of 20. So the most number of passengers that we can have in jeepney is only 20. So x plus 14 is less than or equal to 20. So what could be the value of x? So we do the transposition process. We have to transpose the positive 14, which will become a negative 14. And we subtract 20 by 14, it becomes 6. So x is less than or equal to 6. Problem number 3. A box can hold at most 10 kilograms. It already contains 6 kilograms, so how much more weight can you add? So take note of the word at most 10 kilograms. So it means that the maximum is 10 kilograms. So if we are to let our variable x represent an unknown, it would be the extra weight in that box. So equation will now become x plus 6 is less than or equal to 10. Again, 10 kilograms is the maximum weight. So if we are to solve for the value of x, it will be transposing the 6 on the other side. So it becomes 10 minus 6. So x now is less than or equal to 4. Problem number 4. Didi wants to buy a jacket that costs 1,200 pesos. He has 950 pesos saved. How much more does he need? So here, our x represents the money still needed. And for the equation, it would be 950 plus x, since we are looking for that extra amount that Didi needs in order to buy the jacket. It should be greater than or equal to 1,200. So to solve, we have 950 plus x greater than or equal to 1,200. We transpose the 950, it becomes negative, and so 1,200 minus 950 is 250. So x should be greater than or equal to 250 in order for Didi to buy a new jacket. Are there any more questions? So this time, please reflect on the following questions. How are inequalities different from equations? how can inequalities help us in real life? So, once you're done answering this reflection question, please send your answer via Canvas inbox. Again, via Canvas inbox, then answer your formative assessment number 4.